Good morning, everyone. Welcome to Thursday, April 23rd. Today, we are going to be going over additional examples on factoring. It is important today that while you are following along, that you have all of the tools necessary to be able to understand what I'm referencing. So if you're taking notes on this, I highly suggest setting up your papers something like this, or something like this, where on the left-hand side, you ask yourself these three questions. Is there a GCF? How many terms are there? And then what's the method? And then over on the right-hand side, you give yourself enough space to actually do the work. The IXL code that we're going to be covering today is capital TAH. I don't think the capitalization matters, but just in case you want to follow along and do some actual examples. Some of the tools that you want to have out in front of you, if you go to our Google Classroom, it's probably a good idea to have the flowchart that I've referenced multiple times. So you want to make sure that you have that. We will be using this flowchart kind of to help us with our thought process as we go through the different stages of factoring. So I'm just going to open this in a new window, and then I do believe it will allow me to download it after I do that. Yeah, so right here, after you open it in a new window, you can click download. And for those of you who are working on a computer, that will allow you to open it up outside of the web. So now that I have that open, I'm going to go to IXL and I'm going to type in TAH. It's just called factor polynomials. So what's nice about this, well, I think it's nice, you're not going to like it very much, is that it doesn't give you really any indication of what method you're supposed to use or anything like that. It just gives you a polynomial, and we're going to go through the different steps and the thought process of figuring out what the heck are we going to do and how are we going to factor this polynomial. All right, so without further ado, let's get started. This looks to be our first one, so I'm going to write it down behind me, and you can write it down as well if you're following along with your notes. So our first one on our IXL practice is 9mn minus 3m plus 15n minus 5. All right, and we're just going to go through the same thought process that we normally would over here. So I'm going to stop the share real quick so you can see it. All right, so for those of you following along, the first question we ask ourselves is there a GCF? So I noticed that not all of them have the same variable. These two seem to have common factors, and so do these two, but nothing on all four. So that's no, there is no GCF here. How many terms are there? There are 4 terms. So if we go over to our flowchart, if it's 4 terms, there's really only one method here. We're going to do factor by grouping. That's what's kind of nice when it's 4 terms, is that there's only one way to do it, and that's factor by grouping. Okay, so here we go. I noticed that there's addition here, so that means I can just put in my groups. I don't have to bring any subtraction symbols along. Now I'm finding the GCF of the first 2 terms and the GCF of the last 2 terms. So I noticed that 3 goes into 3 and 9. So I'm going to write both of these using 3. 9 is 3 times 3, and then it looks like we have an m times an n minus 3 times 1 times m, right? Because that's basically the second one. Over here, I know 5 goes into 15 and 5, so I'm going to write 15n as 5 times 3 times n minus 5 times 1. All right, what do they have in common? Let's find the GCF. So it looks like the first 2 have 3m in common, and the second one just has 5 in common. So let's go ahead and factor out, oops, I was thinking about the second 2, not the first 2. Let's go ahead and factor out the 3m. Oh, by the way, our factoring method, I got ahead of myself, didn't I? Our factoring method here is grouping. Okay, let's go ahead and factor out the 3m from the first 2, and then we'll factor out the 5 from the second 2. Come here. All right. So when I factor out 3m from the first 2, what's left behind? Let's see. It looks like I have 3n left behind in the first one and 1 left behind in the second one. Let's do a quick check. 3 times 3 is 9, m times n is mn, and 3m times 1 is 3m. So that makes sense. In the second one, I'm factoring out a positive 5. When I factor that out, what am I left with? Hopefully it's 3n minus 1. Otherwise, we can't do our common binomial factor. Looks like 3n and minus 1. All right, because I have that common binomial factor, that means that my factor by grouping is going to work. So whatever they have in common, That's your first binomial, 3n minus 1. And then the second binomial is the combination of the two other GCFs, 3m plus 5. That's the answer that I got. Let's see if IXL agrees, because if it doesn't, then that's kind of embarrassing. Okay, over here, looks like our answer is 3m minus 1, oops, minus 1, and 3n. Is that right? No. 3n minus 1. Oof, that would have been bad. And 3m plus 5. All right, let's see. By the way, look at the time. That took me about 4 minutes to do, and I'm moving pretty quickly. So these are things that I'm looking for, is like, how much time are you spending on these types of problems? Let's see. All right, there we go. Now, it looks like this is another factor by grouping example because it has 4 terms. So I'm just going to try to skip until we get a different type. All right, here we go. So now this is a different example. And again, I didn't do the second example because it has 4 terms. So that's just another factor by grouping one. All right, this one is very different. So I'm going to go ahead and write this one down. Go ahead and write it down as well, if you're following along. So what stands out to me is that this has 3 terms and it has a leading coefficient. So that usually means something else. Let's see. So I'm going to write this one down. 25w squared minus 40w plus 16. And then we're going to go through the thought process of using the 3 questions and the, let's get the glare out of there. There we go. And the flow chart. Okay, look for a GCF. I don't see a GCF here because 5 and 5 are really the only factors of 25, and that doesn't go at 16. So no GCF here. How many terms does it have? 1, 2, 3. 3 terms. So let's take a look at our flow chart. All right, if it has 3 terms, that means it's a trinomial. Is there a leading coefficient? Yes, 25 is out in front. That means we can't just use P's and Q's. Is it a perfect square trinomial? Meaning, is the first and the last term, are they perfect squares? Let's see. Is 25 a perfect square? Yes, it is. Is 16 a perfect square? Yes, it is. So that means all we have to do to determine if it's a perfect square trinomial is test the middle term. So let's do that, because if it is a perfect square trinomial, it's actually a lot less work. So take the square root of the first term, the square root of 25w squared, which is 5w. Take the square root of the last term, 16, which is 4. Then we're going to multiply them and add them together to see if they add up to the middle term. 5w times 4 is 20w, and 20w plus 20w is 40w, and look at that. That's the middle term. So that means that, yes, this is a perfect square trinomial. I'm just going to write perfect square trinomial, which means it only really takes 2 more steps to be able to factor. And again, remember, you have to test the middle term. Just because the first and the last term are perfect squares doesn't always mean that it's a perfect square trinomial. So let's set up our 2 binomials. First term in both is going to be the square root of the first term, which we already found to be 5w. Second term is going to be the square root of the last term, which is 4. And then we ask ourselves, it's kind of a funky looking 4. Let's redo that 4. There we go. Then we ask ourselves, positive or negative, plus or minus? Well, the middle term is negative, which means both of these actually have to be negative, which means our binomials contain subtraction. Now, you could leave it like this, but your future Algebra 2 teachers are going to want you to simplify that to 5w minus 4 squared. All right, let's see if IXL agrees, because if they don't agree, then we did something wrong. Okay, I'm going to go ahead and set this up. Looks like I can, IXL lets me do all of that. 5w minus 4, and then don't forget to put the squared in there. If you don't put the squared in there, we'll not consider it correct. All right, let's see. Hey, we got it right. Okay, then it brings us to another one. Look at this. Oops, I just went backwards. Sugar. The beauties of owning a Mac. Sometimes I accidentally go backwards. Let's go back here. Factor polynomials. All right, cool. Well, I was about to give us a factor by grouping. Let's see if it does that again. Oh, look, that actually worked out nicely because I was afraid it was going to give us a factor by grouping example. This is another different one. We have n squared minus 2n plus 1. Let's do this one next. go ahead and write this down. Set up your 3 questions. Does it have a GCF? How many terms does it have? What method are we going to use? In this video, I'm going to try to avoid doing a bunch of problems that are the same style. That's why I'm skipping the ones that have 4 terms, because we've already done factor by grouping example. 2n plus 1. Okay, let's go ahead and look at this one. So does it have a GCF? Well, because there's no leading coefficient here, unless all of them have a variable n, usually means that there's not a GCF. So no GCF here. How many terms? 3 terms. So let's take a look at our flowchart. Again, 3 terms means it's a trinomial. Is there a leading coefficient? No, there is no leading coefficient, which means, yay, we just get to use factor by p's and q's. So p's and q's will be our factoring method. So here we go. To do p's and q's, you find 2 numbers that have a sum of the middle term and a product of the last term. Here we go. So what times what equals 1. So when I add them together, I get -2. Well, there's only so many ways to get 1. I think our answers are -1 and -1. -1, -1. So here we go. Our 2 binomials are n minus 1 and n minus 1. Wait a minute. Oh my gosh, I didn't even realize this, but this is a perfect square trinomial. Look, it turned out to be a product of the same exact binomial. So you could actually write that as n minus 1 squared. Oh yeah, look at that. So n squared is a perfect square, and so is 1. And the middle term is double the square roots of the first and the last. I didn't even realize that, honest to goodness. I really didn't. So, oh well, whatever. Like, honestly, when there's no leading coefficient, I would just use p's and q's. But yeah, we ended with n minus 1 squared. So look at that. Let's see what IXL says. And again, if they don't agree, then we have to figure that out. N minus 1, put up my little square root guy, squared, and it agrees. Okay, ooh, this is a different one. All right, let's go ahead and do this as our next example. So I'm gonna erase my board while you get your paper set up. All right, we always ask ourselves the same first question. Is there a GCF? Where is my other pen? Did I lose it? Oh, there it is. Okay, so this one is 9c squared minus 4. All right, let's go through our questions. Is there a GCF? I don't think there's a GCF of 9 and 4, because 3 doesn't go into 4, 2 doesn't go into 9, no. How many terms is it? There are 2 terms. So let's take a look at our flow chart and see what it wants us to do. Okay, when there are 2 terms, that means it's a binomial. Is it a difference of 2 squares? Because if no, then really all you can do is factor out a GCF. And if there's no GCF, then it can't be factorable. So let's see, is it a difference of 2 squares? Well, it is a difference. 9c squared is a perfect square, and so is 4. So yes, we're going to be using difference of 2 squares. All right, there we go, difference of 2 squares. So I'm going to set up my answer, my product of 2 binomials. Take the square root of the first term. The square root of 9c squared is 3c. The square root of 4 is 2. That means my first term is 3c. 3c. My second term is 2. And there's no middle term. So are these addition, subtraction? What are they? Well, if there's no middle term, that means there's actually a 0 term. And the only way to get 0 is to make 1 addition and 1 subtraction. 3c plus 2, 3c minus 2. Let's take a look at our IXL and see if they agree. So we have 3c minus 2, 3c plus 2. I think I flipped that, but it doesn't matter. At the adding and subtraction, the order doesn't matter. Submit, and we're good to go. All right, looks like we have another 4-term polynomial. We haven't done one of these since the very beginning, so we'll go ahead and do one. And then I'm actually gonna, I think I'm gonna jump a level and look at some that are a little bit more challenging. I've received a lot of questions about factor by grouping, so that's why I don't mind doing another one of these. 2t cubed plus 2t squared plus 9t plus 9. All right, Well, the first thing that stands out to me here is that it is 4 terms. There is no GCF. It's 4 terms, and hopefully by now you don't need to see the flow chart. When it's 4 terms, there's only one way to factor it, and it's factor by grouping. So here we go. Step 1, put in your 2 groups. Step 2, find the GCF. So it looks like 2 goes into those 2 and 9 goes into those 2. So this is 2 times 1 times t times t times t. This is 2 times 1 times t times t. Over here is 9 times 1 times t and 9 times 1. Step 3, what do they have in common? So that's 2 and t times t. Over here is just 9. Step 4, factor it out. We're going to factor out 2t squared over here and a positive 9 over there. I just feel like setting it up. Step whatever I'm on, what do they have left over? Looks like they have 1t, which just means t, plus 1. And over here, 1t, which is just t, plus 1. And last step, whatever step it is, factor it out. So common binomial factor, t plus 1. The other one is 2t squared plus 9. Okay, let's see. Who knows, right? Okay, so we have t plus 1 and 2t plus, 2t plus 9. Is that what it is? Oh, 2t, so, oh, that would have been terrible. 2t squared plus 9. Whew. Thank goodness I checked my work. All right, brilliant. Okay, so it is going to take you a little while to get out of the lower SMART scores. And I can tell you right now, this is a difference of 2 squares, just looking at it, because it's a difference and both of these are perfect squares. So we're going to go ahead and jump a level. Let's see what happens when we get all the way up to 49. Ah, this is an interesting one. Let's take a look here. We haven't actually dealt with one like this before, and this makes me excited because I wanted to do one like this. You know, factoring, math, it all gets me excited. So again, I can feel your eye rolls happening, but whatever. Okay, 32w squared, 32 squared minus 200. All right. This is why it is so important to go for a GCF first. Oh, I'm just so excited that this happened. Okay, so look for a GCF. Yeah, I think 32 and 200 have a GCF in common. And here's the thing though, what GCF do they have in common? I'm pretty sure 4 goes into both of them. No, 8. Does 8 go into both of them? 8. You know what? Let's just grab a calculator. Like, why not? Let's see. 200 divided by 8 is 25. Yeah, 8 goes into both of them. So let's go ahead and factor out 8. So yes, this has a GCF. And that's why it's important to find the greatest common factor. Like I could have just done 2 or 4, but then I noticed 8 goes into both. And so that's why we're going to factor out 8. So this becomes 8 times whatever we have left. So 8 times what is 32w squared? That's 4w squared. And 8 times what is 200? That's 25. And again, I just used a calculator because why not? All right, now we look at what do we have left over. So how many terms are there left? There are 2 terms. So that means because there was a GCF, we're either done or it's a difference of 2 squares. Remember, look at your flow chart. It's either a difference of 2 squares or you're done because there's only so much that you can do with 2 terms. Is it a difference? Yes. Is 4w squared a perfect square? Yes. Is 25 a perfect square? Yes, which means this is a difference of 2 squares, which you wouldn't have noticed here because 32 and 200, actually I think 200 is, but 32 is not a perfect square. So without factoring out that GCF, you really wouldn't know. All right, so I'm going to set up my final answer first, and then we're going to go in and find our perfect squares. Okay, so remember, in a difference of 2 squares, we start by taking the square root of the first term. Square root of 4w squared is 2w. We take the square root of the last term. Square root of 25 is 5. All right, so here we go. Let's fill it in. First term in both binomials is going to be 2w. Second term is going to be 5. And because there is no middle term, one of them's positive, one of them's negative. And that's our final answer. Let's see what IXL says, because again, it's all about what IXL says. So don't forget the 8. If you don't put the 8 in there, then it's not going to be right. 2W plus 5. Oops. 2W minus 5. Oops, that's an equal sign. Minus 5. All right, 2W. Let's submit and see what it says. Ah, great job. Look at that. Okay. This looks to me like a pretty simple P's and Q's one. So let's go ahead and jump another level. Let's see if we can get something a little more challenging. This also looks like a P's and Q's, but this one looks a little bit tougher. So we'll go ahead and do this one too. Why not? I don't know why this is considered a challenge problem, but you know, what do I know? All right. Okay. Z squared minus 26Z plus 25. All right, let's go through this process. This one will be pretty quick. Is there a GCF? No, because there's no leading coefficient. That means there's not a GCF here. I think you can tell that. Nope. It has 3 terms. And remember, when you look at your flowchart, that's not the flowchart. When you look at your flowchart, 3 terms, you always ask yourself, is there a leading coefficient? So in this case, there is no leading coefficient. That means we get to use P's and Q's. That means we're going to be able to factor this pretty quickly. So we're going to use P's and Q's. So what two numbers have a sum of the middle term, the product of the last term. So what times what is 25? So when I add them together, I get negative 26. I noticed while I set this up, the 25 is 1 away from 26. So that usually means 1 going to be one of your factors. Let's see. So if I used 1 and 25, how do I get negative 26? Because 1 plus 25 is positive 26. What if I make them both negative? Yeah, that worked. So my first term is negative 1, second term negative 25. Let's do a quick check. Z times Z is Z squared. Negative 1 times negative 25 is positive 25. And negative 1 plus negative 25 is negative 26. I think that's right. Let's check IXL. Alrighty, I'll put in my 2 binomials, why not? Okay, so the first one, Z minus 1. The second one, Z minus 25. Submit, awesome. Okay, this one's a little bit different. We haven't seen one like this. So we'll go ahead and do this one together. What smart score are we at, by the way? Look at that, we're already at a smart score of 89. I mean, I did skip 2, but I mean, we're at a smart score of 89 and I haven't seen one that's been like crazy ridiculous hard yet. So that's reassuring. Okay. 2y squared plus 11y plus 12. All right. Question 1, is there a GCF? So because there's a leading coefficient, I'm just going to check this. Wait, did I write that down right? Oh, I did. Okay. Just make sure. Does 2 go into 11 and 12? No. So that means no GCF here. Identify the number of terms. There are 3 terms. So let's take a look at our flowchart, which by the way, on your assessment, you can totally use this flowchart. Like print it out, write it down, take a picture of it, use it. No leading coefficient means P's and Q's, but there is a leading coefficient, so that won't work. All right, so with a leading coefficient, first check, is it a perfect square trinomial? 2 and 12 are not perfect squares. So that means it's one of these, which is just a lot more work. So you get to use supergrouping, double cross, or slip and slide. Y'all know me, I love my slip and slide. So I'm going to do slip and slide. Slip and slide. And if you want to do supergrouping or double cross, you go for it. And then you check your answer with us. All right, slip and slide. Step 1, slip it. 2 times 12 to the ending term. And now we're in an alternate universe where we're dealing with a totally different trinomial. Our trinomial has just become y squared plus 11y plus 24. Where did that 24 come from? From slipping 2 down to 12. 2 times 12 is 24. In this alternate universe, we get to use P's and Q's because it's a trinomial with no leading coefficient. That's why students like this one, by the way, more. It's because P's and Q's is a little more straightforward, so slip and slide is usually a little bit better for most students. I encourage you to try it if you haven't tried it yet. What two numbers have a product of 24 and a sum of 11? I'm thinking 8 and 3. Is that right? 8 and 3? Yes. Okay, so we're still in our alternate universe because you don't come out of the alternate universe until you slide at the end. Set up my two binomials. First term is y. Second term is going to be positive 8 and positive 3 because those are your P's and Q's. All right, time to leave this alternate universe. We're going to slide because that's undoing. So here's the thing. The slip is really multiplying. You're multiplying the first term by the last term. So to undo that, you have to divide the last term by 2. That's essentially what we're doing. We're dividing both of these terms by 2. So we're undoing that multiplication. All right, and then we simplify. 8 divided by 2 is 4. Yay, that's simplifiable. Can I simplify 3 divided by 2? No, so I'm just going to slide that 2 out in front because really what I'm doing is I'm just multiplying both of these terms by 2. Think of it like MPOE, right? That undoes the fraction, and then I'm left with 2y plus 3. That's really what you're doing with that slide. All right, let's see, y plus 4 and 2y plus 3, which by the way, if you did it by supergrouping or double cross, you should have the same answer. And it might be 2y plus 3 first and y plus 4 second, but it shouldn't matter. The method that you use should not matter. Okay, I got y plus 4 and 2y plus 3. Submit. Hey, oh, challenge zone. Crazy. Oh, this looks nuts. That looks like a really fun grouping example. What are we at? A 91? Do we want to do this one together? Yeah, why not? Let's do it. Maybe this will be our last one. I'll see what the next challenge looks like. I don't know about you guys, but I have fun factoring, so I could do this all day. In fact, I do pretty much do this all day. Trust me, as much as you're factoring, I'm factoring just as much, guys. All right, here we go. 32RS. 32RS plus 48R plus 22S plus 33. All right, this one looks kind of fun. She says with a evil smile on her face. Okay, is there a GCF? I'm going to say no because really only 2 goes into these 3 terms and 2 doesn't go into that one, so no. There are 4 terms, and that's the nice part. If it's 4 terms, there's only one way to do this. Grouping. And not super grouping, just regular old-fashioned grouping. And it's already addition. I mean, I don't know how this is a challenge problem. You guys are gonna like totally nail this. All right, step 1, I'm gonna keep track of my steps this time. Step 1, group. Step 2, GCF. GCF of 32 and 48. 4 goes into both. That seems low. 4. 8? Does 8 go into 48? Yeah, it does. Okay, so this is 8. So 32 is 8 times 4. Oh, almost lost that. And then times R and S. And 48 is 8 times 6? No. That does seem low. Well, let's just go with it and see what happens. Over here, 2 times 11 times S and 3 times 11. All right, let's see what they got in common. We've got an 8 and an R in common, and over here we have an 11 in common. So let's go ahead and factor those out. 8R and a positive 11, and let's see what we have left over. That leaves us with a 4S plus 6 and a 2S plus 3. So our all right, let's see where this is a challenge problem now. The issue here is that these are not common binomials. 4S plus 6 is not the same as 2S plus 3. So I know where I went wrong. I went wrong because 4 and 6 still have a common factor. That common factor is 2, which means 8 was actually not the GCF here. If I were to factor out 2 times 8 is 16. So that means I didn't find the greatest common factor. I just found a common factor. So let's go back and redo that. Now I know that's why finding the greatest common factor, it's not called a CS, it's called a GCF for a reason. Turns out 16 was the greatest common factor here. I should probably use a calculator more often or a multiplication chart. 32 is 16 times 2 times R times S. 48 is 16 times 3 times R. So here's a little hint. When you're dealing with something this complicated, you know, the second one was a lot easier to do. So you know what you're trying to get. You know you're trying to get 2 and 3. That kind of gives you a hint as to what's going on over there. All right. Now I realize they have 16R in common. Let's pull that out, 16R. And that leaves us with, I forgot to grab out the 11s, 2S. Plus 3. There we go. Now it's a common binomial factor, which means now I can factor it fully. Okay, IXL, I see you trying to sneak that one in there. Makes sense now why that's a challenge problem. Almost got me, but you didn't. All right, let's see. 2S plus 3 and 16R plus 11. Let's see what IXL says. And we got it. Oh, that looks like fun. You know what? I'm going to let you guys do those on your own. Okay, so hopefully that helps. We've gone over quite a few examples here on IXL TAW or TAH, excuse me. The biggest thing and the best resource for you to use right now is this resource right here. This is the same exact thought process that I go through. And then I actually talked to Mrs. Aureli yesterday. If you don't know Mrs. Aureli, she is an Algebra 2 teacher and also a pre-calc teacher and a trig teacher and like an honor teacher. And she does a lot of really awesome things. And I showed this to her and she said that this is what she has her kids do in Algebra 2 as well. So this is the thought process. This is like the holy grail of thinking through factoring. So some of you are able to do it without this, but I highly suggest you just have this open, or if you have a printer, or take a picture of it on your phone and like have it next to you while you're working. I cannot stress enough how important this is, okay? Well, that is it for today. And remember that if you have any questions or any issues with factoring, please email me, talk to me, and I hope that you have a lot of fun factoring with your IXL practice. Bye, guys.